Imagine a railway so advanced that trains from two completely different track systems can run smoothly on the same route without stopping for wheel changes, without unloading cargo at the border, and without the massive delays and extra costs that have frustrated international trade for over a century. In 2026, China has turned this vision into reality by completing the world's first large-scale dual-gauge cross-border railway system. This engineering breakthrough has the potential to transform freight movement across Eurasia, reduce logistics costs, and strengthen regional economic ties. Welcome to Insight Empire. Today, we deliver a powerful, fact-based deep dive into how China built this revolutionary dual-gauge railway and why it changes everything for global trade, infrastructure development, and geopolitics. If you're new here, make sure to subscribe and hit the notification bell so you never miss important strategic breakdowns. Let's explore this historic achievement in complete detail. The breakthrough, world's first true dual-gauge railway. In mid-2026, Chinese railway authorities officially announced the successful completion and testing of key sections of the China-Mongolia cross-border railway. The project stands out because of its innovative dual-gauge design. It features parallel tracks running side by side. One track uses the standard gauge of 1,435 millimeters, which is China's national standard and the most common gauge worldwide. The second track uses the broad gauge of 1,520 millimeters, which is the standard in Mongolia, Russia, and many former Soviet Union countries. This side-by-side configuration allows trains operating on both gauge systems to use the same corridor without interruption. The railway connects China's extensive rail network directly to Mongolia's resource-rich mining regions, most notably the giant Tavan-Tolgoi coal mines. Construction on the Chinese side moved forward rapidly using advanced domestic technology, making this the first purpose-built, high-capacity, dual-gauge international railway system in the world. Why railway gauges have been a persistent global problem. Railway gauges, the distance between the two rails, have created technical barriers since the earliest days of rail transport in the 19th century. Different nations adopted different standards based on engineering preferences, political decisions, or historical circumstances. China primarily operates on the international standard gauge of 1,435 m. Mongolia and Russia use the broader 1,520 m gauge inherited from Soviet infrastructure. At traditional border crossings, this difference forces trains to stop completely. Cargo must be physically transferred from one train to another, or expensive wheel-changing facilities must be used. These processes can delay shipments by several days, increase transportation costs by 20 to 30%, and reduce the overall reliability of supply chains. The new dual-gauge system elegantly solves this long-standing issue by providing dedicated tracks for each gauge standard within the same physical corridor, eliminating the need for transshipment at the border. Engineering details and technical achievements, the construction of this dual-gauge railway demanded exceptional engineering skill and precision. The parallel tracks share the same general route alignment, but maintain completely separate rail pairs with their own ballast, sleepers, and fastening systems. Engineers designed reinforced embankments capable of supporting the different load characteristics and axle weights of both standard and broad gauge trains. Bridges and culverts were built to handle both systems safely, while signaling, communication, and safety networks were fully integrated to manage mixed operations. Chinese contractors utilized high-speed rail construction expertise developed over the past 2 decades, including automated track-laying machines, laser-guided welding systems, and real-time quality monitoring sensors. The border terrain presented multiple challenges, including open grasslands, varying soil stability, extreme temperature fluctuations between summer and winter, and occasional seismic risks. Special drainage systems were installed to manage heavy seasonal rains, and environmentally sensitive construction methods helped minimize disruption to local wildlife. The project also includes newly built stations, passing loops, maintenance depots, and advanced safety infrastructure specifically designed for dual-gauge operations. Power supply systems and digital monitoring tools ensure smooth coordination between Chinese and Mongolian trains. Strategic importance for China and Mongolia. This dual-gauge railway serves several important strategic objectives. For China, it creates a more reliable and efficient import channel for critical resources such as coal, copper, and other minerals from Mongolia. This strengthens energy security and helps diversify supply chains away from vulnerable sea routes. The project is also a key component of China's Belt and Road Initiative, which focuses on improving connectivity with neighboring countries and expanding trade networks. For Mongolia, the new railway offers a modern export pathway to Chinese markets and ports. As a landlocked country, Mongolia has traditionally faced high transportation costs that limited its mining potential. The dual-gauge link is expected to significantly boost the country's mining sector, which is vital for its economic growth and government revenue. It also creates opportunities for future extensions that could connect with broader regional rail networks, including potential links toward Russia and Central Asia. Economic and trade impact. The economic benefits of this project are expected to be substantial. By removing border delays, the dual-gauge system can dramatically reduce transit times and lower overall logistics costs. Shipments that previously took days at the border can now move with minimal interruption. This improved efficiency is projected to increase trade volumes significantly between China and Mongolia. Mongolian mineral exports to China are likely to rise sharply, while Chinese manufactured goods, machinery, and consumer products can flow northward more smoothly. The enhanced connectivity may also attract third-country trade, allowing goods from Europe or other regions to reach Mongolian markets through combined rail services. In the current global environment of supply chain restructuring and resilience building, this dual-gauge approach offers a practical and scalable model for overcoming technical barriers in international trade. Environmental considerations and challenges. Major infrastructure projects like this one naturally come with environmental considerations. Construction activities can temporarily affect local wildlife corridors, vegetation patterns, and water resources in the border region. Both China and Mongolia have publicly committed to environmental protection measures, including wildlife monitoring programs, revegetation efforts, and sustainable construction practices. Independent long-term ecological assessments will be important as full operations begin and traffic volumes increase. From an operational perspective, coordinating two different national railway systems requires continuous diplomatic and technical cooperation. Differences in regulations, maintenance schedules, safety protocols, and train specifications must be carefully managed through bilateral agreements. Early operations will focus mainly on freight transport, with potential future passenger services being studied. Comparison with other global rail projects, China already operates the largest high-speed rail network on Earth, famous for its speed, punctuality, and massive scale. This dual-gauge freight project complements that success by solving international interoperability challenges. Unlike some European initiatives that push for complete gauge standardization across borders, or India's ongoing efforts to convert lines to a single gauge, China has chosen a pragmatic parallel track solution that respects existing national standards on both sides. The innovation prioritizes high-volume, heavy freight capacity over passenger flexibility, making it especially suitable for resource transportation corridors. If successful on a large scale, this model could inspire similar dual-gauge developments in other parts of Central Asia, Southeast Asia, and regions where historical gauge differences continue to create friction. Global implications and future outlook. This achievement represents more than just steel rails and concrete structures. It demonstrates how focused innovation and engineering determination can overcome barriers that once appeared permanent in global trade. In an increasingly interconnected but still technically fragmented world, practical solutions like dual-gauge railways can improve efficiency, reduce transportation costs, and support lower carbon emissions by making rail freight more competitive against road and sea transport options. Looking forward, full commercial operations are expected to expand steadily over the coming years. Future project phases could extend the network deeper into Mongolia's mining heartland and eventually integrate with Russian rail systems, potentially creating longer, seamless Eurasian freight corridors. The addition of digital technologies, such as smart signaling systems, automated logistics platforms, and real-time tracking, will likely further enhance performance and safety. At Insight Empire, we closely track these kinds of megaprojects because they reveal important larger patterns, how nations use infrastructure, technology, and strategic planning to reshape economic geography and global power dynamics. China's dual-gauge railway stands as a concrete example of turning technical challenges into opportunities for progress and cooperation. This project has the potential to accelerate investment in similar cross-border infrastructure solutions around the world. It proves that with sufficient resources, expertise, and political will, long-standing engineering problems can be solved effectively. Thank you for watching this detailed strategic breakdown. If you value fact-based insights into transformative megaprojects and global trends, please like this video, share it with others who are interested in the future, and subscribe to Insight Empire for more powerful content. Drop your thoughts in the comments. Do you think dual-gauge railways will become a new global standard, or will other technologies eventually replace them? Let us know what you think.